Here with the week 4 problem set solutions for the Sigma group. This is the first video. We're going to be looking at problems 1 through 7. I'm mostly going to be showing you the algebra methods for working through here. Every once in a while I'll show you some of the test taking strategies that I like to do. The first one, I'm going to use some algebra here. I know I don't like to use it, but here seems to me the best way to do it. We're going to have two equations, one for plan A and one for plan B. The first one has a flat fee of $20 per day, and we're 5 cents each kilometer. Do not make that silly mistake of doing 20 plus 5. It's got to be 20 plus 0.05 to put it into dollars and cents. And that 0.05 gets multiplied by x to figure out how many miles, or kilometers I should say, it's going to take for them to cost the same amount. Now for plan B, it's $15 flat fee, and it is 7 cents per kilometer. And now we just need to solve this problem here. If we subtract 0.05 on each side, and also subtract 15 on both sides. I'm going through this rather quickly. I assume you guys know this algebra. That's gone, giving us 5 equals 0.02x. Divide both sides by 0.02. We get an x value of 250 kilometers, which is answer choice E for number 1. That's an E. Kind of looks like an E. Problem number 2. We could work backwards here by plugging in answer choices into the second equation. Probably just as easy to go through forwards with the algebra. On the first equation, we have -2 parentheses x plus 9 equals -20. Could distribute. Why bother? Divide both sides by -2. Give you x plus 9 equals 10. Subtract 9, you get x equals 1. Now that's not the answer, but you'll notice that x equals 1 is an answer choice to see if you're paying attention. We then need to plug into the next equation, which is -4x squared. No big deal. -4 times 1 squared, well that's -4 times 1, which is -4, giving us answer choice A as the correct answer. Problem number 3. In this problem we have two different equations. This is a system of equations. The only problem is they're not linear, so it makes it a little bit more difficult. Best bet, my idea, you could plug in answer choices if you want. They give you A values. You could therefore find the B values from that. Probably just as easy to go ahead and work through using substitution. That's what I'll show here. I'm going to solve for A by adding B on both sides, giving me A equals 5 plus B. Then I'm going to take that 5 plus B value, that's a B, not a 6, and I'm going to plug it into my other equation. My other equation is A squared plus B squared equals 30, so I'm going to do B plus 5 squared plus B squared equals 30. Okay, well, oops, that squared should be on the outside there, right? So on this first binomial, I'm squaring it, which means I have to do B squared plus 10B. If you're not sure what I'm doing here, you should go back and watch the video on foiling. Plus B squared equals 30. So I have 2B squared plus 10B plus 25 equals 30. Subtract the 30 over, giving me -5. And just a second here. Oh, that's where it was. This is actually a minus B squared. So my b's actually, they don't become 2b squared, they cancel out. So I have 10b plus 25 equals 30. Let me bring that up over here so we have a little bit more room. 10b plus 25 equals 30. Subtract 25 on each side. We have 10b equals 5. So b is 1/2. And if b is a half, plugging back into my original equation, we end up getting an A value of 5.5, which is the same thing as 11 halves answer choice A for number 3. Got lost in my own work there for a second. On to number 4. We'll bring it up here. Which of the following is a factor of 2x squared minus 7x minus 4? Okay. We have a quadratic here. We could look at this a couple of different ways. You could factor it. And we know we're going to have a 2x and an x. Okay? And then we need to figure out what else is going on here. We know one of the terms has to be a positive, one of them has to be a negative. The one that is not associated with the 2 is going to be the positive, and the other one is going to be the negative. And I'm just using my mental math here. I know I'm going to have a minus 4 and a plus 1. Don't like that way, or you can't think that way, that's okay. You can then look to see at the answer choices. Answer choice C is the correct answer, giving us 2x plus 1. Well, if 2x plus 1 is a factor, then that means when it's set equals 0, it works. Subtract 1, divide by 2. That means that x equals negative 1/2 is a possible answer choice. Now, you'll know where the answers lie if you graph the function in the calculator and just look to see. And in fact, if you did do that, plug that in to y equals, you would get negative 1/2 as an answer choice. Number 5, the sum of the solutions, okay? In this problem here, again, we could go right to the calculator and find the values that are the solutions and add them together, or we could try and factor it. I'll show you a method that I like for factoring when a does not equal 1, and if you like it, send me a message and I can send you more information on how to do that. It's called slide and divide. Anytime the first value is not 1, slide it to the end and multiply it, giving you x squared plus 7x plus 12 equals 0. And now factor like you normally would. This is a nice and easy factoring problem, giving you x plus 3 and x plus 4. Now whatever you slid at the front, which was a 2, you come back and divide in the end. And if it goes in evenly, like it does in the second one, go ahead and divide it, x plus 2. If it doesn't, like we see here, we are going to move it in front, giving us 2x plus 3. Now we can solve them, setting each one equals 0. First one gives us x equals negative 3/2. Second one is negative 2. When we combine these, we get negative 3/2, which is answer choice B. Not too much room here. Let's see if we can squeeze number 6 in. So the equation has how many distinct real solutions? So we have 4x squared plus 9 equals 0. Well, we can do this in here nice and easy. Subtract 9 on each side. You have 4x squared equals negative 9. Hold up. Stop there. You have a negative number and you're about to take a square root. So you know it's not going to work. So there are no solutions. Remember, solutions are the same things as answers, as roots, as x-intercepts. So another way to look at this problem is to look at the graph and see how many times it crosses the x-axis. In this case, it doesn't cross at all, so you have 0 distinct solutions. Answer choice A. Come on back.